Hello, I'm Scott Brown with Green Wind and Other Home Energies. What I have here in my hand is a diode bridge rectifier for three-phase circuits. This came out of an alternator, and it is capable of 90 amps. This is your negative. This is your positive. The heat sinks themselves are the conductors for the outputs. This is L1, L2, and L3. Your outputs from your alternator go to those three inputs. On each side of this terminal here, there's a diode. This copper right here does not connect with this aluminum heatsink. Comes close. And it goes to a diode, and the other side of the diode goes to here. Each one of these has a diode on this side, and on this side, each one of these have a diode. But these diodes on this side are turned around so that all the polarities are facing in this direction on this one and that one. So this one's facing the terminal and this one's facing away from the terminal. So this winds up being negative and this is positive. The negative is your supply of electrons. So electrons come in here, they go through this diode and out here. And the same on this one. Depending on whatever your phase, when any one of these become negative, the electrons flow from these terminals this way. When they're positive, they're drawn from this side. And because they're all connected, they make a full circuit. But anyway, we've got that set up here. You notice up here on this wind turbine, dual permanent magnet rotor axial flux wind turbine, this has a terminal here, and a terminal here. Plus it has a terminal here, here, and here. Well, the way this is wired up, this terminal right here is your finish, and this one is your start to the same coil. Then you finish, then you start. You finish, and you start, you finish, and you start. So this is one coil, another coil, and your last coil. The reason why this is wired up this way, and these are placed like this, it makes it easier to wire in star or delta. To wire these in star, you short all three of these. So I've got the black lead going from here and going to here. And then I've got this green lead, which is just a continuation of shorting these three out, going from this terminal to this terminal. So these three are connected. This puts all of the starts, or finishes, doesn't really matter, all of the starts are wired together. Then the three finishes come out. Gives you a pattern of having a dot in the center, all connected, one coil, and another coil. They call it star or Y. To connect these in delta, all you'd have to do is connect the start of this coil to the finish of this one, and the start of this coil to the finish of this one, and the start of this coil to the finish of this one. This is one coil, this is one coil, so each time you jump up, all you're doing is putting all three of these coils in series. And you still leave these outputs in the same position. Nothing changes except the way that you connect up from here on down. From here out is the same, so this would still be L1, L2, and L3. Sorry, the color coding isn't right. These are the only colors I had as far as jumpers. So this is on here. I've got this meter sitting over here on 40 volts DC. And I'm not going to turn this very fast, but I'm going to turn it. Now that I have two rotors on here, it doesn't take very much to get up to that 11 volts that I showed you before. This is very slow. It's one rotation per second. This is almost 60 RPM. There's 13. Here's 120 RPM. 2, 3, 4, 5, 6 seconds, 7 seconds, 8 seconds, 9 seconds, 10 seconds, 8. So we're looking pretty close to up around 20. That's very good. Easy to do charging volts. I can crank this up. Whoop, I lost my grip. Let's give it one more try here. I bet I can get this going much faster. Almost hit 40 volts there. Not that bad. The real fun thing about this is, as you see, it's still up around 19 there. Notice how it just slowed down real good. Show you the efficiency. Spins like a bicycle wheel until you draw power from it. You turn this mechanical energy into electrical energy, and you use the electrical energy, that's what happens. All of a sudden, it draws all the energy out of the unit. You just shorted it all out. So, that's exactly what happens. Short these two out, and it will stop rather abruptly. Anyway, there's your demonstration. I'm Scott Brown with Green Wind and other home energies. Many good things to you and yours. Alright, here's our amp scale. Alright, let's crank it. 1, 2, 3, 4, not even 30 RPM. Let's see, I get it to hold down. It's hard to crank. I reach 2 amps. 1 turn, 2 turn, 3 turn. I can't reach 60 RPM by hand. Anyway, it was showing you 2 amps. That's how efficient and convertible that is. Thank you, buddy. Take care. Okay, one more little demonstration. Here I try to crank this real fast. As fast as I can get this thing to go because it's shorted out, because the meter's on amps. How come it's still turning? Look at that. Spins as free as a bicycle wheel. Why? Because it's not generating any amps at this low, extremely slow RPM, but you try to speed it up and you can't get any more out of it. That's why I'm saying it's a very efficient motor or alternator. 1.8 amps. That goes back to just easy as a bicycle wheel. So if I disconnect this out of the meter, I just love playing with that. No problem. I'm Scott Brown with Green Wind and other home energies. Many good things to you and yours. Plug it in.